So here we have the function cosine of log of x whole squared. So we need to find its derivative by using the chain rule. So here we are going to assume that log of x whole squared is equivalent to x. Then we have to find only the derivative of the cosine function, which should give us negative sine x. So x here is log of x whole squared. So this is an assumption. So we assume that log of x whole squared is equivalent to x. So we will need to multiply it to the derivative of our assumption, which is log of x whole squared. Now what we can see here, we have something of the form x raised to the power of n. So now if we assume that if log of x is equivalent to x, then we have derivative of x raised to the power of 2. So here we can apply the power rule to give us twice of x. So that means we have negative sine log of x whole squared multiplied 2. So here we can apply the power rule. So log x is here behaving as x. So we have 2 times log of x raised to the power of 2 minus 1 multiplied to the derivative of the assumed value, which is log of x. So finally we get negative sine log of x whole squared multiplied to 2 log of x times derivative of log of x, which is simply x. So this is the derivative of our function cosine of log of x whole squared. Let's move on to the next question. So here we have the function log of cosine of x squared. So let's try to find out the derivative of this particular function with respect to x. So this will be equals to, so here we are going to make an assumption that cosine of x squared is equals to x. So this is an assumption, so that means we need to find the derivative of log of x. So that should give us 1 over x. So 1 over x here is cosine of x squared. Since it is not x, so we are going to multiply it to the derivative of cosine x squared. Now we are going to make a second assumption here that x squared is equivalent to x. So that means we have to find the derivative of cosine of x. So that should have given us sine, which is negative sine x squared, and that will be multiplied to the derivative of our assumption, which is x squared. So negative sine x squared over cosine squared x is going to give us tangent of x squared multiplied to the derivative of x squared, which is simply twice of x. So finally we have negative 2x times tangent of x squared. So this is the derivative of log of cosine x squared. Let's move on to the next question. So here we have the function e raised to the power of ax times secant x times tangent of 2x. So here we have three functions. So we're going to apply the product rule by considering the e raised to the power of ax times secant x as the first function and tangent of 2x as the second function. So we have the first function, which is e raised to the power of ax times secant of x. So this will be multiplied to the derivative of the second function, which is tangent of 2x, plus the second function, which is tangent of 2x, and that will be multiplied to the derivative of the first function, which is e raised to the power of ax times secant of x. So we have e raised to the power of ax times secant of x multiplied to, now let's try to find out the value of tangent of 2x. We know that the derivative of the tangent function is secant squared x, but here we have 2x. So we're going to make an assumption that 2 of x is equals to x. So that should give us secant squared 2x. But since it's not x, it's instead 2x, so we need to multiply it to the derivative of 2x. So this is the chain rule plus tangent of 2x. Now we have to apply the product rule here, because now we have two functions, e raised to the power of ax times secant of x. So let's assume that this is the first part and this is the second function. So this will be multiplied to e raised to the power of ax, which is the first function, multiplied to the derivative of secant of x, plus secant of x multiplied to the derivative of e raised to the power of ax, which is equals to e raised to the power of ax times secant of x multiplied to secant squared 2x, and derivative of 2x is simply going to be 2, so let's put it in the front. So we have 2 in the front, so plus tangent of 2x multiplied to e raised to the power of ax. So the derivative of the secant function will be secant of x times tangent of x plus secant of x multiplied to e raised to the power of ax. So here we're going to assume that a of x is actually x, then that should give us the function itself, e raised to the power of ax, but since it's an assumption, so we need to multiply it to the derivative of ax. So finally we get 2e raised to the power of ax times secant x times secant squared 2x plus tangent of 2x whole multiplied to e raised to the power of ax times secant of x times tangent of x plus e raised to the power of ax times secant of x. And here we have the derivative of ax, a being a constant, we can pull it out, which leaves us with derivative of x, so that's simply 1. So this is the final value of the derivative. So where we can also pull out e raised to the power of x as the common factor, and we can also take out secant x. So we have e raised to the power of ax times secant x as the common term, so that leaves us with 2 times secant squared 2x, so that will be left from the first term. From the second term we'll have tangent of x times tangent of 2x, so this multiplied to this entire term will give us the second term, plus in the third term we have a times tangent of 2x. So this is the derivative, required derivative of the given function. So let's move on to the next question. So here we have the function given by log of 3x plus 2 minus x squared times log of 2x minus 1. Let's try to find out the derivative with respect to x. So first we're going to apply the derivative to each of the two terms. So we have derivative of log of 3x plus 2 minus the derivative of x squared times log of 2x minus 1. So here what we are going to do, we have the product of two functions, so we'll need to apply the product rule. So we'll consider x squared as the first function and log of 2x minus 1 as the second function. So that gives us let's apply the product rule first, then we'll apply the chain rule. So we have derivative of log of 3x plus 2. So I'm leaving this derivative as it is because we'll need to apply the chain rule here. So we'll have negative x squared times the derivative of log of 2x minus 1 plus the derivative plus log of 2x minus 1 multiplied to the derivative of x squared, which will give us derivative of log of 3x plus 2 minus x squared times the derivative of log of 2x minus 1 minus log of 2x minus 1 times the derivative of x squared. So now let us apply the chain rule. So we have to find the derivative of the log of 3x plus 2. So if we assume that 3x plus 2 is x, then the derivative of the logarithmic function would return us the value 1 over 3x plus 2. But since this is an assumption, so we'll need to multiply it to the derivative of 3x plus 2 minus x squared multiplied to, similarly here we're going to assume that 2x minus 1, if it were x instead of 2x minus 1, then the derivative of the logarithmic function should have returned us with 1 over 2x minus 1. Then we need to multiply it to the derivative of our assumption, which is 2x minus 1 minus log of 2x minus 1 minus 1 times derivative of x squared is simply 2x, which is obtained by using the power rule. So we have 1 over 3x plus 2 multiplied 2. So derivative of thrice x is going to be 3 and derivative of 2 is going to be simply 0. Minus x squared times 1 over 2x minus 1 times derivative of twice x gives us 2 and derivative of 1 is 0. Minus of 2x times log of 2x minus 1. So rearranging all the terms, so here we have 3 over 3x plus 2 minus 2x squared divided by 2x minus 1 minus 2x times the log of 2x minus 1. So this is the final derivative of the given function with respect to x. So here we have the function log of square root of x minus 1 over x plus 1. So we need to find its derivative by using the chain rule. So let's find the derivative. So derivative of log of something. So this something is, let's assume that this something is x, then we should get 1 over the something, which is square root of x minus 1 divided by x plus 1. But since it is not x, so we need to multiply it to the derivative of that particular something, which is square root of x minus 1 over x plus 1. So we can take the square root of x plus 1 to the numerator, so that will become x plus 1 over x minus 1. Now we need to find the derivative of x minus 1 over x plus 1 raised to the power of half. Now we're going to assume that x minus 1 over x plus 1, if it were x, then we can apply the power rule. So we have square root of x plus 1 over x minus 1 multiplied to half times x minus 1 divided by x plus 1 whole raised to the power half minus 1. So half minus 1 is simply negative half multiplied to the derivative of x minus 1 over x plus 1. So this is equals to 1 over square root of x plus 1 over x minus 1 times half, or we can now flip the numerator and the denominator. So we have x plus 1 over x minus 1, so the exponent will become positive, times, now we find out the derivative using the quotient rule. So we have x plus 1 whole squared, and the numerator will have x plus 1 multiplied to the derivative of x minus 1, which is simply 1, minus x minus 1 multiplied to the derivative of the denominator, which is also 1. So that leaves us with square root, let's write the half in front. So we have square root of x plus 1 over x minus 1 multiplied to square root of x plus 1 over x minus 1 times, so we have x plus 1 minus of x plus 1 divided by x plus 1 whole squared. So the x and x goes away, and we have half multiplied to square root of x plus 1 over x minus, so this is repeating twice. So multiplication of the square root with itself will take care of the square root. So we'll have x plus 1 over x minus 1 multiplied to 2 divided by x plus 1 whole squared. So the 2 and 2 goes away, x plus 1 from the numerator and the denominator goes away, leaving us with 1 over x minus 1 times x plus 1. So the product of x minus 1 and x plus 1 is simply equals to x squared minus 1. So this is the derivative of log of square root of x minus 1 divided by x plus 1.